Hey guys, it's Miss Gebhardt, and I'm going to go through today and do some notes on the formation of Earth. I'm going to break these notes up into like 3 sections. The videos will be shorter, but just kind of be aware of that. So the introductory slide will sort of go over all the vocab covered, and then there will be three videos or 3 parts to this video to kind of cover all of it. All right, so all of the vocabulary that's going to be covered is the inner and outer core, the mantle, the crust, the tectonic plates, Pangea, convection currents, the rock cycle, divergent, convergent, and transform boundaries. So let's start with the layers of the Earth. And so we will go from the inside and we'll work our way out. On your notes, you may want to draw out the best you can, kind of sketch out the inner core, outer core, kind of the layers of the Earth, and maybe write a little bit of facts about it. But the inner core is it's very, very hot. It's under extreme amounts of pressure, and it's very warm in there. So warm being like you're gonna melt yourself off because it's some crazy, ridiculous amount of degrees. But the inner core is solid. It's made of mostly of iron and nickel, and it's about 3,200 to about 3,900 miles below the surface. Okay, so that's pretty far down there. Okay. Next, we have the outer core. The outer core is the only liquid layer. Okay. And mostly iron and nickel is what it's made up of, so same to the inner core. It's roughly about 1,800 to 3,200 miles below the surface, and about 1,400 miles thick, so it's pretty thick. And we're getting to temperatures that are about 6,000 degrees Celsius. So that's pretty hot. Hotter than anything anybody has ever experienced in this class. Oops, sorry, going too far there. Next we have the mantle. And within the mantle, it's about 1,800 miles thick, so it's the thickest layer. It's quite thick. And this is, again, we've got hot temperatures, okay? So we haven't cooled off yet, but we're going to be cooler as we move closer towards the crust. But this is a semi-solid sort of rock, so it's kind of like jello, and that's kind of all there is to the mantle. And we're going to talk a little bit more when we talk about convection currents with the mantle, but that's kind of the basic composition. And then finally, we've got the crust. And the crust is very hard and rigid. You have to think that's what we're standing on. That's what we live on. It's only a few miles thick, so it's not that huge comparatively to everything else. And that's where things are going to shift. If we have continents moving or whatever, it's because the crust that's what's actually doing the shifting. Okay. I'm sorry. Let's move on. So next we have to talk about what tectonic plates are. So tectonic plates, they're pieces of Earth's crust. Okay, so they have to imagine like they're actually like plates of Earth, and they're not all connected together. Okay, so there's gaps between these plates, and these are what are going to cause the continents. Like these are the movement. Is these plates actually moving. They're causing the continents to shift from one area to the next. A term Pangea is what the continents used to look like way long ago when all of the continents were connected as one large massive supercontinent, which was called Pangea. And the plates will move by a process called convection currents, which we'll go over in just a second. But let's take a look at Pangea. So you can see on the 5 different diagrams or pictures. We start up at the top left, and that's 250 million years ago, and it goes from left to right, and then bottom left to right, and then the very bottom, which is present day. So from present day to Pangea, that's 250 million years. Those continents have done a lot of shifting because the plates have done some moving. They move because of a process called or through convection currents. Okay, so this is a movement of that solid semi-rock in the mantle. The warmer material is going to rise all the way up to the surface, and as it rises, it's going to start cooling. When it cools, it sinks. So I want you to think about your house. It's hotter upstairs than it is downstairs. That's because warm air rises. It's lighter, okay, so to speak. So the material that's warmer is lighter as it rises up. But when it hits the surface, you got to think it's very hot in the core, in the inner core and outer core in the mantle. It's getting progressively cooler as we get towards the crust. So it's going to cool down, and then it's going to sink. So we kind of create this cycle effect. Okay, so here's a diagram of what that would look like. So here we go. It's rising up, hot, 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 and then it's going to cool down and it's going to shift. And you see how these arrows move? That means that the continents are going to split apart at this point right here. Over here, the continents are going to actually come together. And that is it for this first part of the video. Please make sure you look and watch the second part, which is going to cover the rock cycle, and then the last part, which is going to cover the plate boundaries.